Welcome students. This lecture video is the part of Fluorescent Public School digital learning program. So today we continue our chapter 3, periodic classification of elements. And in this chapter we already complete the development of periodic table, the topic which includes different kind of periodic tables, their demerits and merits. Today we start the different kind of radii. Talk about the different kind of radius. Okay, let's start. So basically it is quite impossible to calculate exact value of radius of an isolated gaseous atom. So you must note it that a radius is always calculated in a bonded form of an atom. If that atom is not in a bonded form, then it is impossible for us to calculate exact radius of an atom. So what we know about this radius? So the order of this radius is angstrom order, and that angstrom order is equal to 1 angstrom is equal to 10 raised to power minus 10 meter, that I already talked in chapter first, some basic concept in chemistry. You can see here this is a kind of atom that is spherical completely in nature, and that represent the radius, that is represented by small r, and the order of that radius is around 10 raised to power minus 10 meter. If we ask about the what would be the order of the radii of nucleus, if you see the nucleus, so nucleus is lying in somewhere at the center of this atom. Nucleus will also spherical in nature, and the radius order of the radius of nucleus is around Fermi order, that is 10 raised to power minus 15 meter. But in this lecture we talk about only radius of atoms. Okay, so it is an elementary idea of the radius. There is a term radii, which is a plural form of the radius. Okay, so we talk about the types of radii. So I put a basic classification here. You have to understand it quite easily. Okay, you can also draw this flow chart in your textbook also. So basically, radii are classified into two categories. One is atomic radii, and another is ionic radii. Okay, now atomic radii may classify in different types. Okay, three types of atomic radii we discuss in this lecture. These are covalent, metallic, and Vander Waal. And this type of radii, atomic radii, is completely based on the radius of atoms which bonded with the help of different kind of interactions or bonds. Suppose two atoms are bonded with the help of covalent bond, then the radii of atom is called covalent radii. If two atoms that are bonded with the help of metallic bonds, then the radius become metallic radius. If two atoms are not bonded with each other, then the radii between them is called van der Waal radii. Okay, so van der Waal radii is basically used for the noble gases. Okay, so atomic radii is further divided into how many portions? Three portions. While atomic radii is divided into two portions, that is cationic and anionic radius. So what about the atomic radii? The first type of atomic radii is covalent, metallic, and van der Waal. And what about the ionic? Ionic radii may be cationic or anionic radius. Okay, the radius of an anion is called anionic radius, while the radius of a cation is called cationic radius. Okay, you already know the anion and the cations. Okay, if you ever read out about anions, so the anions are the those species which having negative charge, while cation are those species which having positive charge. So first we talk about the covalent radius. You can see here there are two atoms. There may be S2 atom, it may be O2 atom, it may be nitrogen, that is N2 atom. Okay, so two atoms are bonded with the help of covalent bonds. Okay, and first we talk about the diameter. Okay, so the diameter, the length of the bond is the diameter of a atom. You can easily correlate it like that. The diameter of an atom is the length of a bond between two atoms. Is it clear? So the length of the covalent bond is from that end to center of the another atom. Okay, and half of the distance is called its radius. First we measure the diameter or the length of the bond, and then we just make it half, then we got covalent radius. So what about the definition? It is the half of the distance between two nuclei of covalently bonded atoms. If we take some example of diatomic molecules like hydrogen, oxygen, nitrogen, then we see here that there are two atoms and the half of the distance between two nuclei of covalently bonded atoms. That means covalent bond must be there. Okay, so this is all are about covalent radius. Come to the next, that is metallic radius. Metallic radius is generally found in D block elements, S block elements. Okay, so this is all are about metallic radius. As similar to the covalent radius, it is again the half of the distance between two nuclei which are bonded with the help of metallic bonds. Basically, the bonded atoms in case of metallic radius, the size of the atoms are similar because both the atoms are belongs to same elements. Suppose we talk about the silver atoms, then the size, all the silver atoms are identical in their shape and size. While in case of the covalent radii, it is not possible always that both the bonded atoms, okay, are of similar size. But in case of metallic radius, both the both the atoms which are bonded with the help of metallic bonds must have similar shape and size. So if we talk about the definition, it is the half of the distance between the nuclei of two adjacent metallic ions. As you know that the uh, metals inside the metallic crystal are exist in a form of metallic ions. Okay, and these metallic ions are surrounded by the sea of free electrons. Okay, so we use this term two adjacent metallic ions in the metallic crystal. Okay, come to the next. This is Van der Waal equation, and not a Van der Waal equation. This is a Van der Waal radius. Generally, this Van der Waal radius is fine for find in between two non-polar molecules, or especially for the noble gases, because the noble gas atoms are exist freely. They individually exist. They never interact with the other atoms. Or we can use this Van der Waal radius for the covalent type of compounds. But the basic thing is that in between the molecule there are no interaction. Both are non-polar. Suppose we take an example here. This yellow colored two atoms represent here hydrogen and hydrogen atoms. So it is a S2 molecule and it is another S2 molecule. So how many kinds of radius you may represent here? One type of radius is Van der Waal radius that already shown on your screen, and you may talk about the covalent radius also. See the click sign here, cursor here. This radius is called covalent radius. Okay, this radius is called covalent radius, while this radius is called Van der Waal radius. If two atoms are having no physical bonds in between them, then it is called Van der Waal radius. If they are bonded with the help of bonds, and they belongs to, if two atoms are belongs to same molecule, then they must represent the covalent radius. If two atoms in which we find the radius and they are not belongs to the same molecule, then it is called Vander Waal radius. So by seeing this diagram, we observe that Vander Waal radius is the largest one among all the radius. Okay, and especially for the noble gas, we talk about noble gases, then the radius must be Vander Waal. So in the respective period, the individual atomic radius is maximum for the for the noble gases that belongs to group number 18, 0 group. So it is half of the distance between two atoms that are not bonded or within the same molecule. They must belong to different molecules. Is already written here, non-bonded molecules. That means there is no physical bond in between two molecules. So generally above radius used to define radius of a novel gas atom, and it is largest among all of the radius. On to the next, ionic type of radius. As you know that cations are comparatively larger in size, while cations are smaller in size, while anions are larger in size. You can see here by this diagram. Suppose this is a NaCl type of crystal. This yellow atom represents the Na plus, while this blue color sphere represents the chloride ion. Okay, so how we find this ionic radius? We first calculate the diameter, and then just make it half. It is a half of the distance between two ions which are rarely touched with each other. Why they are rarely touched? Why they are rarely touched? Because ionic interactions are having no physical bonds in between ions. They are simply electrostatic type of attraction. That's why it called rarely touch with each other. There is a gap in between two spheres, cation and anion. Okay, so cesium is the having largest ionic radii in the periodic table. That means Cs unipositive ion having the largest ionic radii in the periodic table for the cationic side. Okay, come to the next. If we compare the ionic radii with the parental radii, then there are two types of ionic radii. One is cationic and another is anionic. Then the common trend may be observed that cations are always having less radius than the parental atom. While in case of anions, they are bigger in size than parental atom. You can see here unipositive sodium ion having radius less than its parental sodium atom, while the cesium positive ion having less radius than its parental atom cesium. But in contrast, the fluoride ion having greater radius than the fluorine atom, while in case of chloride ion having large radius than the chlorine parental atom. So the common trend is anionic radius is the largest one, then parental radius, then parental radius is greater than cationic radius. Okay. Come to the next. We will also provide the answers or reason for that kind of trends. But first, anionic radius is larger than parental radius. These are the conclusions which we made from these facts. Second one is cationic radius is smaller than parental radius. Parental radius means the origin of cation or anions from those atoms, and these atoms are called parental atoms. Suppose Na plus is obtained from Na by losing one electron. That means the parental atom is neutral Na atom. So two conclusion we made through this slide, that anionic radius is larger than parental radius, while cationic radius is smaller than parental radius. You must remember it because it is quite important. Come to the next. Have a look on different atoms and their ions, corresponding ions, and compare the radius. This is just a uh, supplementary diagram. You do not learn the data provided by me. You just see the you just compare the ions and their parental atoms, okay, and correlate with the conclusions. If you see here, you find here that the anions is of bigger size than their parental atoms, while the cations are of smaller size than their parental atom. Okay, I will give the 2 minutes. You correlate this diagram with the above conclusion. Okay, that's it. Come to the next comparison between the radii. So in this lecture, we talk about covalent radius, metallic radius, okay, Vander Waal radius, ionic radius, and its two type, cationic and anionic radius. So we made some conclusion that which radius is the larger, which radius is the smaller than the others. So basically, we find the conclusion that Vander Waal radius is the largest one and covalent is the least one. Okay, and is not always true. Okay, it may changes sometime, exception is always there. So in case of metallic and ionic, it may interchange. Okay, so general, I provide you the general order, it's not always true. But if someone asks that which one is the largest radius, then you have to give the answer in a favor of Van der Waal radius. Okay, then ionic you can see ionic is only an ionic type, then metallic, and then covalent. Covalent is the least one because in case of covalent, orbitals are overlapped with each other, and because of their overlapping, the bond length become decreases. While in case of ionic, there is only no bond situation, and there is a ionic interaction, electrostatic type of interaction. They are not both the bonded atom are not so close with each other. That's why ionic radius is larger one. In case of Van der Waal, the atoms in between which we find this radius, they must be non-bonded. If they are non-bonded, then it is maximum. This is a basic comparison. Okay, and we can say it is a conclusion of all slides, all type of radii. Okay, so this is all are about today lecture. Okay, I provide some questions, you have to give the answers. If you have any doubt, you can ask. Next slide, in next lecture we include the periodicity. Okay, first question, order of atomic radius is, I already told you that the radius of atom belongs to angstrom order, that is 10 raised to power minus 10 meter. Question number second, anionic radius is always, think about it, we made some conclusion, we made two conclusion from the ionic radii slide. The first conclusion is anionic radius is always greater than parental radius. So the answer is greater. And the second conclusion is cationic radius is always smaller than parental radius. Student, this is again, I told you that it is important statements. Okay, so you must remember these two statements. Next is fourth, explain following. The radius of the chlorine atom is less than chloride ion. Chlorine is a parental atom, chloride ion is a anion. So the radius of that question asks about the reason. So why chloride is bigger in size than chlorine atom? So the answer goes to Z effective. That is effective nuclear charge. Okay, and that is a core attraction which is exerted by the nucleus to the outermost electron present in a valence shell. So somewhat this attraction from the nucleus get decreases, and because of that, that electron lie far apart from the nucleus, and because of that, radius will increases. So we talk about this Z effective and effective nuclear charge and nuclear charge in our next lecture. So wait for it. But I just provide the in a single line answer. Must memorize it. Okay. and correlate it with our next slide. So due to decrease in Z effective, in this lecture you just understand that Z effective is a kind of attractive force which is exerted by nucleus to the outermost electron that present in an atom. So due to decrease in Z effective, due to decrease in attraction, size will increase. Next is size of Na plus is smaller than parental sodium atom. So the answer uh, goes in contrast that due to increase in Z effective, if the attraction from the nucleus is increases, then electrons will lie towards the nucleus, due to which size of nucleus constrict and due to which size become decreases. So the answer is increase in Z effect. So this is all are about today lecture. In our next lecture, we include nuclear charge, effective nuclear charge, shielding effect, okay, and different kind of periodic trends. That you, some of them you already learn in class 10. These are atomic size, ionization enthalpy, electron gain enthalpy. So this is all are about today lecture. Okay, you must note all these questions and the flow charts in your notebook also along with the dates. If you got some confusion, okay, you may write in comment section.